supposed to go, trying to find all by design, feeling all this power, reckless and devour, traveling the sound, never backing down, wanting to find more.
Hello and welcome everybody. It is December 18th, 2023, and I am the Shy Hat, and we're here to complete day 18 of the Advent of Cyber event hosted at TryHackMe.com. Let me turn on my mouse highlighter so that we can see what I'm pointing to on the screen. All right, so today we're going to be engaging in some Linux server forensics. I'm going to paste the URL for the Advent of Cyber event from TryHackMe in the chat right now. So if you wanted to work alongside us and try to solve the challenge at the same time, then that's how you would do so. Okay, so without further ado, let's jump into today's task. All right, so it's day 18, and what we should do first is we should start our virtual machine that we're going to use for today's challenge. You can do so by clicking on this Start Machine button right here, and that's going to split the browser pane into two. The left-hand side is going to have the TryHackMe web page, and the right-hand side is going to have the virtual machine that we're going to be interacting with to solve today's challenge. So, while the virtual machine is spinning up, initializing, and we're going to take a look at what we're going to be learning about today. So the story so far is that McGreedy is very greedy and doesn't let go of any chance to earn some extra elf bucks. During the investigation of an insider threat, the blue team found a production server that was using unexpectedly high resources. This might be a crypto miner. They narrowed it down to a single unapproved suspicious process. It has to be eliminated to ensure that company resources are not being misused. For this, they must find all the nooks and crannies where the process might have embedded itself and remove it. Okay, so what are we learning in today's task? In today's task, we will identify the CPU and memory usages of processes in Linux. We're going to kill unwanted processes in Linux. We're going to find ways a process can persist beyond termination, and we can remove persistent processes permanently. Okay, so for today's exercise, we do need to start up a VM, which we are currently waiting on right now. And there is split screen available, which is this right here. This is split screen. But after the VM initializes, what we're going to do is we're going to put the VM in its own web browser tab so that we can get a larger view of what's going on. So the first thing we need to do is identify the process. So Linux gives us various options for monitoring the system performance. Using these, we can identify the resource usage of processes. One option is the top command. This command shows us a list of processes in real time with their usage. It's a dynamic list, meaning that it changes with the resource usage of each process. All right, so we see that our virtual machine has finished initializing over here. So what we can do is we can put the virtual machine in its own browser tab by going down to this button right here, which is View in Full Screen, and we click that, and a new tab will open up, and now our virtual machine can be accessed from this browser tab. We'll return to the original browser tab, and then we're going to close out this view over here by clicking on this button over here, which is labeled Exit Split View. So we click on that, and then now we can see the TryHackMe web page all in full screen, and we can also see the virtual machine in full screen as well. So we're going to go down to identifying the process, and we were talking about the top command, which can let us see what processes are happening inside of a Linux server. Okay, so in the virtual machine tab, we're going to click on that. We're going to open up a terminal, and we can do that by either clicking on this shortcut button, or this shortcut button. Okay, so I'm going to click on that, and it's going to open up a terminal. We're going to resize the terminal so that we can see what's going on in the terminal nice and big. Maybe that's big enough. We're going to make this a little bit wider. Okay, and then we're going to use the top command to see the top processes that are being used inside of the Linux machine. Okay, so we see here that there is one process over here that has been started by the root user with the process ID of 666, and it's using 99.7% or sometimes 100% of the CPU processing time. And the command being used is this one right here, A. Okay, so this is kind of suspicious. Let's go back to the web page and read all about it. In the terminal, the output changes dynamically with the resource usage of the different processes, similar to what we see in the task manager in Windows. It also shows important information such as the PID, process ID, user, CPU usage, memory usage, and the command or process name. In the above terminal output, we can see that the topmost entry in the output is the process that uses 100% CPU. We will return to it later, but for now, we can see that our shell is not interactive and only shows the command's result. To exit from this view, press the Q key. So we're going to exit out with the Q key. Okay, so now we're going to go on to killing the culprit. At the top of the output of the top command, we found our culprit. It's the process named A, which uses unusually high CPU resources. In normal circumstances, we shouldn't have processes consistently using very high amounts of CPU resources. However, certain processes might do this for a short time for intense processing. The process we see here consistently uses 100% of the CPU resources, which can signify a hard-working malicious process, like a crypto miner. We see that the root user runs this process. This process's name and resource usage gives a suspicious vibe, and assuming that this is the process unnecessarily hogging our resources, we would like to kill it. Disclaimer: in actual production servers, don't try to kill processes unless you are sure of what you're doing. If we wanted to perform forensics, we would take a memory dump of the process to analyze it further before killing it, as killing it would cause us to lose that information. However, taking a memory dump is out of scope here. We will assume that we've already done that and move on to termination. We can use the kill command to kill this process. However, since the process is running as root, it's a good idea to use sudo to elevate the privileges for killing the process. Let's try to kill the process. Note that you will have to replace this number right here with the PID that is shown in your top command's output. Alright, so we need to use a sudo command to kill the process that we saw. Okay, so for us, the process ID number is 666, but for you it might be something different. But we're going to use the sudo command, sudo kill, and then the number of the process, which in our case is 666. Okay, so that ran successfully, and now we're going to do the top command again to see if the process is still running. Okay, so we see that in the top command, we see that this A command is still running, and it's also still using 100% CPU resources. But now, the process ID is different. So this implies that after we killed the process, that the process restarted again, but this time has a different process ID number. All right, so we're going to press Q to quit out of this, and then we're going to go back to the web page for an explanation. Whoa, the process is still there. Did our command not work or what? Wait, the PID has changed, and so has the time. It looks like we successfully killed the process, but it has been resurrected somehow. Let's see what happened. Okay, so here we're talking about checking the cron jobs. Our first hint of what happened with the process will be in the cron jobs. Cron jobs are tasks that we ask the computer to perform on our behalf at a fixed interval. Often, that's where we can find traces of auto-starting processes. To check the cron jobs, we can run the command cron tab-l. A nice description is shown in the comments, lines starting with the hash character in the below terminal that can help us understand the cron jobs format, followed by the cron jobs that are currently active. Okay, so we're going to run cron tab-l. So we're going to copy that and run it inside of our virtual machine. Okay, and we see that there are two cron jobs that are being used right here. But for an explanation of what they do, let's take a look at the web page. Well, it looks like we have no luck finding our process here. We say that the only cron jobs run by the user are about running a VNC server. But wait, the process was running as root, and each user has their own cron jobs. So why don't we check the cron jobs as the root user? Let's switch to the root user and see if we find something there. We first switch users using sudo su, which switches our user to root. Then we check for cron jobs again. Okay, so inside of the virtual machine, we're going to do sudo su to switch to the root user, the one with the highest privileges on the machine. And then we're going to run the same command that we did before, which is cron tab-l. Okay, so we see that in here, everything in this file has been commented out, so that there are no cron jobs being run as the root user. Okay, so back at the web page. Well, tough luck. No cron jobs running here either. Where else can they be? Okay, so now we're going to check for running services. Maybe we should check for running services that might bring the process back. But the process name is quite generic and doesn't give a good hint. We might be clutching at straws here, but let's look at what services are running on the system. To do this, we use the systemctl list unit files to list all services. Since the service we are looking for might be enabled to respawn the process, we use grep to give us only those services that are enabled. Okay, so we can copy this command right here, and we're going to run it inside of our virtual machine. And it's going to get a list of the different services that are enabled on the machine. Okay, so there's a lot of different services that are being run on the machine. But if we go all the way up to near the top, we see that there is an interesting name for this service right here. Let's read about it in the web page. We do find something suspicious here. It looks like it has a strange name for a normal service. Let's get more information about this service, starting with checking its status. Okay, so we're going to run this command right here, systemctl status, and the name of the service. Okay, so we're going to copy this command. So a-unkillable.service. Okay, we'll remember that, and then we'll go back down to the bottom of the list. And then we'll paste in the command a-unkillable.service. Okay, and we run that command to get the status of this particular service. All right, so we see here a lot of different information about this service right here. So it's loaded and it's active and running. Okay, so it has this process ID, and it takes up this much memory. And this is the command that it does right here. So here we see a message, Merry Christmas, and also Merry Christmas. And then it starts this, this program right here. All right. So we found the devil in the details. We can see that the service is running the process named A that we couldn't kill. What's more, the service is taunting us with a greeting message. We must kill this service if we were to kill this useless process, getting rid of the service. So now that we have identified the service, let's embark on a journey to get rid of it. The first step would be to stop the service. Okay, we might need root privileges for that, so we need to switch over to the root user. Okay, so here we've already switched over to the root user, so we don't need to do that again. Okay, so we can do this command right here, systemctl stop, and then the name of the service. We'll copy this, and then in here we can press Q to get out of this. And then we copy the command with Control-Shift-V, and then systemctl stop, it is a-unkillable.service. Okay, and that should stop the service. I'm going to clear the screen so we can get text near the top of the screen again. Okay. So let's check the statuses again. So we're going to check this systemctl, check the status of the unkillable service to see if it's stopped or not. Okay, so copy that command. a-unkillable.service. Okay, so the active field says that it is inactive right now. Okay, so we managed to deactivate it. Okay, so yeah, it's not so unkillable now, is it? But let's not stop here. Let's check up on our processes. Running the top command, we see the following. Okay, so we see here the A process that was taking up so much CPU processing time is no longer here. So we'll check on our own machine to make sure that that is the case. So we press Q to quit out of the systemctl prompt, and then we type top to get the processes running. So we see here that we no longer have the A command, which is running at 100% CPU resources. So that's good. So we can press Q to get out of that, and we'll go back to the web page to take a look. Okay, no more unkillable process. Now let's quickly wrap this up by killing the service as well. We continue by disabling the service. So we're going to disable the service by using systemctl disable and then the name of the service. So we paste in this command, systemctl disable, and then a-unkillable.service. Okay, so it says that it's been removed. All right, so we see that the status is still loaded, but it's disabled. The problem here is that the service is still present in the system. To completely eradicate the service, we will have to remove the files from the file system as well. Let's do that. Here we see that the location of the service is etc systemd system/redacted. And the location of the process is etc systemd system-a. To permanently kill the service, let's delete these two files. Okay, so we use this command to delete the first file, the actual binary. Paste this in. Okay, so we remove that, and then we're going to remove what is the name of that that other file. So it says redacted here, but let me take a look up here. So let's see. I'm not too sure. Oh, right. A unkillable service. Right. Okay. So we go down here. So a-unkillable.service. Okay, so these two commands have completely wiped out the unkillable service from our system. Okay, finally, we are now rid of the stubborn service that claimed to be unkillable. To wrap this up, we might run the following command to ensure no remnants are left. This will reload all of the service configurations and create the whole service dependency tree again, meaning that if there are any remnants left, it will eliminate them. Okay, so we're going to reload all of the system control services with this command right here. Paste this in and run it. Okay, and that should be it. And now that means we can relax. The CPU usage is normal, and the persistent process has been successfully eradicated. However, we still want to know who planted the process and what it did. We have already taken a memory dump of the process so that we can analyze it to uncover further information. Come back tomorrow to find out if our suspicions are confirmed. All right, so the last thing we need to do before finishing today's task is to answer these questions right here. So the first question is, what is the name of the service that respawns the process after killing it? Okay, so if you remember, it is a-unkillable.service. Okay, and what is the path from where the process and server were running? So these were all located in the /etc/systemd/system directory. Okay, submit that as the answer. All right. So the malware prints a taunting message. When is the message shown? Choose from the options below. So if you remember, we saw the taunting message inside of the service description, which is not randomly or after a set interval or on process termination. So that means that the answer must be number 4, all of the above. Okay? And if you enjoyed this task, feel free to check out the Linux Forensics Room. All right? And everybody, if you feel like learning more about Linux, you can take a look at my YouTube channel at the Shy Hat, and we can see that we have a number of different videos that teach about Linux OS operations. So we have our intro over here, and we have 3 different workshop videos that guide you through learning about Linux. So here, the first 2 incorporate the Bandit CTF, which is very popular and is like a gamified version of learning Linux commands. And the third workshop we have uses the TryHackMe education platform, and also deals with a little bit more in depth about learning Linux OS operations and commands. All right, so with that, we finished today's challenge for Advent of Cyber on the tryhackme.com website. Join us next time for day 19. We never know what topics they're going to be. Actually, I think we got a pretty good guess. We're going to do some memory forensics on the file, on the memory dump that we did. So it's probably going to be memory forensics tomorrow. But until then, everybody, I hope you have a good day, and we'll see you next time.